Hello again, pre-calculus students. In this video, we're going to talk about some properties of logarithms, and I will make some assumptions that you remember some of the basic operations of logarithms. So, let's talk about change of base. If I want to get an exponent out of the exponent, I want to solve this, then I know that I can take the log base 7 of both sides, because the log base 7 of 7 to the x is just x. So I get an answer of x equals the log base 7 of 49, because the log base 7 undid the exponential here, and then I just have the log base 7 of 49. Of course, you should be able to look at this and tell the answer is 2. But there is a rule, and this comes from the if you're multiplying numbers, you're adding their logarithms, just like if you're multiplying numbers, you're adding their exponents. And you can pull this x out front here because of that property. And then I don't know what the log base 10 of 7 is. I don't know what the exponent of 10 that gives me 7 is, but I know it's a constant. I know it's a number. Just like I don't know what the square root of 7 is, but I can calculate with it because I know it's a number, it's a constant. Same here. So this is just a constant. I'm going to divide both sides by the log base 10 of 7. And what I did, I started in this problem by doing the log base 10 because my handy dandy calculator here only knows 2 bases. It knows base 10 and base e. It doesn't know base 7. So if I'm trying to do a log problem, it has to be in base 10 or base e. So I rewrote this problem in base 10. And now I could just ask the calculator for this number and this number, divide them, and I get an answer. Now, it doesn't matter what base I use. If I had used base e, you do that same problem with base e, I'd get the ln of 49 over the ln of 7. In fact, no matter what base I use, it would be the logarithm with that new base of 49 divided by the logarithm of that new base of 7, the original base. So if I want to solve this problem with using a different base, because my calculator doesn't know base 7, I just take the log of this number divided by the log of this number. So here's an example of that. 7 to the x equals 100. I know x has to be somewhere between 2 and 3, because 7 squared is 49, and 7 cubed is, what is that, over 300? 7 cubed is 343. So if I take the log base 7 of both sides, then I get x equals, because this side, the 7 goes away, I get, and this is just the log base 7 of 100. Well, again, my calculator doesn't know how to do this. So I can go log base 10, I can go log base 10 of this number divided by log base 10 of this number. Or I could do the log base e of this number divided by the log base e of this number. And you see, I'm going to get the same number, and I rounded it to 3 decimal. I rounded it correctly to 3 decimal places. Get the same number each time, and it doesn't matter which base I used. So this formula for change of base is written on your it was written on page 221 of your book. It looks really ugly. It's like, oh my goodness. But you'll notice if you want to convert, you don't like a base 7, you want to go to base 10, you take the new base of this number, and then you take the log of the new base of this number, and you divide them. And I've just shown you in a couple of examples why that works. A couple of properties of logs here. When you're multiplying numbers of the same base, you're adding their exponents. So when you're multiplying 2 numbers of the same base, you add their logarithms. So if you're multiplying two numbers here, you're adding their logarithms. If you are dividing two numbers with the same base, you subtract their exponents. So you can see here, if we take the log base b, we're going to subtract the logarithms, just like we would subtract the exponents. So when we divide two numbers and then take the log, it's the same as subtracting the logarithms. I remember in that one problem, I moved the exponent out front. Here's why. If 6 to the 4th is 6 multiplied by itself 4 times, then I know if I'm multiplying numbers and then taking a logarithm, I know that means I can add all the logarithms. And we may not know what this number is yet, but I know if I add it 4 times, that's the same as multiplying by 4. So you can bring that exponent out front in a logarithm. There's a checkpoint problem on page 223. Write that down, see if you understand it. We're still going to go over it in class. That was it for this short video. Have a great day.